Hey there, fellow AI enthusiast. You're really diving deep into agentic AI and pushing the boundaries of what LLMs can do. So we're about to unpack 4 research papers you share on a topic that's harder than a CPU running a benchmark test: LLM reasoning. Get ready for some aha moments as we uncover the latest breakthroughs. And maybe a reality check or two, because it's not all sunshine and roses in the world of AI.
It's true. LLM reasoning is a complex and rapidly evolving field. These papers offer a fascinating snapshot of where we are right now, both the potential and the pitfalls.
Okay, let's unpack this first paper, Chain of Thought Reasoning Without Prompting. Already sounds like it's challenging the status quo, right? We always hear about meticulously crafting those chain of thought prompts. But this paper suggests there might be another way.
What's fascinating about this research is the idea that the reasoning power might already be hiding within the LLM, obscured by how we typically decode responses. They found that by exploring alternative decoding paths, specifically looking at the top likely tokens at each step, instead of just grabbing the single most probable one, they could often uncover these chain of thought reasoning paths without any explicit prompting.
So instead of forcing the LLM down a narrow path with our prompts, we're giving it some breathing room to explore different lines of thought. That almost sounds like giving the LLM more agency to think for itself.
Exactly. And the really compelling part is that when a CAT path was present, the LLM often exhibited higher confidence in its final answer. This suggests that the CAT process is actually contributing to a more robust understanding of the problem.
This is huge for building those more autonomous AI agents you're interested in, wouldn't you say? Less reliance on us painstakingly crafting the perfect prompt and more on unlocking the LLM's own capacity for reasoning. It's like we're giving it the tools to think for itself, rather than just parroting back what we want to hear.
Precisely. This research suggests there's a lot more going on under the hood of these LLMs than we might initially realize. And as we get better at decoding and understanding their internal processes, we could unlock even more impressive reasoning abilities.
Music to my ears. Okay, but paper number 2 brings us back down to earth a bit, with a dose of reality. It's titled, Large Language Models Cannot Self-Correct Reasoning Yet. All in caps, no less. They weren't messing around with that title.
No, they weren't. This paper tackles a big hope we have for LLMs, the ability to self-correct, to catch their own errors and revise their reasoning just like we try to do.
I mean, it feels like they should be able to, right? They're analyzing their own output, after all. It's like having an internal editor always double-checking your work.
The challenge is that while LLMs have shown some capacity for self-correction, this research found they're still quite unreliable at consistently judging the correctness of their own reasoning. They're susceptible to some of the same biases and inconsistencies that we humans sometimes fall prey to.
They gave an example in the paper of an LLM getting a math problem right then on the next attempt to self-correct it. And actually introduced a new error into the previously correct answer. It's like, wait, how did you even get there?
Exactly. It highlights this fascinating tension in LLM development. On one hand, we're seeing these incredible leaps in their abilities, but on the other hand, we're reminded that they don't always think in the same way that we do.
So what does this all mean for you, our listener, who is busy building the next generation of LLM applications, especially those focused on agentic capabilities? It's tempting to think we could just let these LLMs run wild and self-correct, but this paper suggests we're not quite there yet.
You've hit the nail on the head. The key takeaway here is to avoid relying solely on self-correction mechanisms at this stage. While promising, it's still crucial to incorporate robust error detection and handling mechanisms within your LLM systems. Think of it as providing a safety net even as we equip these LLMs with more autonomy.
Consider yourself warned. Now get ready for a curveball, because paper 3 dives into the surprisingly impactful world of order. Yes, order. It's titled, Premise Order Matters in Reasoning with Large Language Models.
This one really underscores the point that, for all their sophistication, LLMs are still sensitive to how information is presented, just like us humans.
It seems obvious when you say it like that, but we often take for granted how much our own reasoning is influenced by the way we encounter information. This paper discovered that even when the underlying logic is sound, simply changing the order of premises fed into an LLM can significantly impact its performance.
It all comes down to how these models process information. They don't have the same innate understanding of context and relevance that we do, at least not in the same way. So the order in which they receive information can dramatically influence their ability to connect the dots and reach accurate conclusions.
It's a great reminder that while we're striving to make LLMs more human-like in their reasoning, they still operate within the constraints of their architecture and training data. They don't have the benefit of years of lived experience to draw upon, so the way we structure their learning environment really matters.
It's like the old saying, garbage in, garbage out, but with a nuanced twist. It's not just about the quality of the information itself, but how it's structured and presented to the LLM that can make or break its ability to reason effectively.
So for you out there building the next generation of LLM applications, especially those geared towards more autonomous agents, this is a big takeaway. Don't underestimate the power of a well-organized prompt. You're not just feeding the LLM information, you're shaping its entire thought process.
Absolutely. And it highlights the importance of understanding the specific strengths and limitations of LLMs at each stage of their development. We can't just throw data at them and expect human-level reasoning to magically emerge.
It's about being intentional, thinking carefully about the task at hand, the type of reasoning it requires, and tailoring the information flow to match. Speaking of which, our final paper zooms in on a technique we've already touched upon. Chain of Thought Prompt. It's titled Chain of Thought Empowers Transformers to Solve Inherently Serial Problems. And it digs into why COT seems to be so effective for certain types of reasoning.
This research makes the case that chain of thought prompting might be addressing a fundamental limitation of the transformer architecture, which, as you know, underpins many of the most powerful LLMs today.
Right. And for our listeners who might not be as familiar with the technical nitty-gritty, transformers are amazing at processing information in parallel. They can handle massive amounts of data simultaneously, which is one reason they're so good at things like language translation or text summarization. But when it comes to tasks that require a specific sequence of steps, things get trickier.
Exactly, and that's where this paper's insights come in. The researchers argue that traditional transformers, while great at parallel processing, struggle with inherently serial problems. They offered a brilliant analogy. Imagine a wide, shallow river. It's great for moving a lot of water across a plain, but if you need to navigate that water through a narrow canyon or uphill, you need a different approach.
And that's where chain of thought prompting comes in, right? It's like building blocks in that river, creating a series of controlled steps that allow the LLM to tackle those more sequential reasoning challenges.
Precisely. By breaking down complex multi-step problems into smaller, more manageable chunks, CATI might be providing a crucial scaffold for transformers to handle tasks that were previously beyond their reach.
So for those of you working on applications that involve things like multi-step math problems, logical deductions, or anything that requires a clear sequential thought process, chain of thought prompting could be your secret weapon. It's like giving your LLM a step-by-step guide to navigate those tricky reasoning pathways.
It's a fascinating area of exploration, and this paper offers compelling evidence that COT might be tapping into something fundamental about how these models process information. It's not just a clever trick. It could be a key to unlocking even more sophisticated reasoning capabilities in the future.
It's like we're giving these LLMs the cognitive tools they need to tackle more and more complex problems, kind of like building a ladder to higher levels of understanding.
That's a great analogy, and I think it highlights the exciting possibilities that lie ahead in this field. But these papers also offer a healthy dose of caution, wouldn't you say? It's easy to get swept up in the hype, but LLMs are still in their relative infancy when it comes to reasoning.
Totally. We've made remarkable progress. But there's a difference between mimicking the appearance of human-like reasoning and truly replicating the underlying mechanism. As you've been listening to this deep dive, what stood out to you the most about the current state of LLM reasoning? What has you particularly intrigued or maybe even a bit wary?
For me, it's the constant interplay between pushing the boundaries of what's possible while acknowledging the limitations. We're seeing these incredible breakthroughs, like the potential for chain of thought prompting to enhance serial reasoning. But we're also reminded that LLMs don't experience the world in the same way we do. Their reasoning is shaped by their training data and architecture, which means we need to be incredibly mindful of potential biases, inconsistencies, and the need for robust error handling.
It's like we're treading this fascinating line between celebrating the potential and proceeding with cautious optimism. So for our listeners who are knee-deep in building the next wave of LLM-powered applications, what's the most important thing for them to keep in mind as they navigate this complex landscape?
I'd say the biggest takeaway is this: don't treat LLMs as magical black boxes. They're incredibly powerful tools, but they're not infallible. These papers have given us valuable insights into how they reason, what trips them up, and where we can focus our efforts to improve their capabilities. It's about understanding their strengths and limitations in equal measure.
It's like being a good coach, right? You need to know how to push your players to reach their full potential while also being aware of their weaknesses and helping them work through those challenges. It's about guiding their development, not just expecting them to magically become reasoning superstars overnight.
Exactly. And that guidance involves careful prompt engineering, understanding the impact of information presentation, and being realistic about the limitations of self-correction mechanisms. We're still in the early stages of this journey, and the more we learn about how these LLMs work, the better equipped we'll be to unlock their true potential.
So for all you LLM enthusiasts out there, keep experimenting, keep pushing the boundaries, but do it with your eyes wide open. Remember, the future of LLM reasoning isn't about replacing human intelligence. It's about augmenting it, collaborating with it, and maybe even learning a thing or two about our own cognitive processes along the way. And that's a wrap on this deep dive into the fascinating world of LLM reasoning. Until next time, keep those AI fires burning.